Okay, and we're back in the hotel hallway. Let's go ahead and talk about this. So I want you guys to get a piece of paper, a pencil, and a calculator if you need it. This is going to act as kind of a quiz. I'm not going to take a grade on it yet. You're going to have a different quiz for that. But as an informal quiz, I want you to pause the video and answer these questions. First of all, what are the coordinates for A and B? Second of all, find the distance between the 2 points, because we just reviewed distance, right? And then last week we talked about midpoint, so please find the midpoint between the 2 points. Remember that a midpoint is a place, not a number. And so you're going to have a comma between your x-coordinate and your y-coordinate for your midpoint. Distance is just a value. So how far is it from A to B? So it's just going to be a single number. So pause it and do that. Okay, now that you've done those, let's take a look. A is at -2, 4, because we always do the x part first, right? X is side to side. Here's my x-axis. Y is up and down. It's my y-axis. So A is at -2 and up 1, 2, 3, 4. So it'd be at -2, 4. B is at 1, -1. For the distance, well, if you still struggle with distance and midpoint, come and see me. I want to reserve this time just for the lesson time. But if you want to go over the answers to these questions, let's work through them together, okay? Okay, moving on. Today we're talking about angles. So whenever you have two rays, this is a ray because it starts at a point and it goes on forever, right? Or where you have two line segments that meet, they meet at a vertex. Well, let's say this is a door and it opens from this doorway here. When it opens up, it has a certain angle to it, right? So these are the sides. Here's the door, here's the doorway, and then there's the angle in between them. They meet at the vertex where the door hinges are, right? So the vertex is always where they meet. Let's talk about how to name these. So this could be called angle A because that's the vertex. It could be called angle 1 because that's the number that we've labeled for it. But, and this is really important, trace these with your finger and call out the points. So we've got C, A, B. We can also go the other way. B, oops, where's my mouse? B, A, C. So CAB and BAC. We always, when we're labeling angles, we'll use 3 points if we need to, 1 point if we don't, or we could use the number that's used for it too. But remember, points are always capital letters, and this is the angle symbol. So when you want to talk about an angle, if you didn't have the angle symbol, this would just be point A. And if you didn't have the angle symbol here, I have no idea what's going on. So make sure you have your angle symbols, make sure you're using your letters, and your vertex is always going to be in the middle. Do you see that? For all of these, the vertex is right there in the middle. Now, it can get a little bit more complicated, so I can't call this angle D because we're talking about angle 1 or angle 2, right? So all of a sudden I need to start using the numbers or the 3 letters. I can't use one letter anymore. Let's take a look. A, D, B. Go ahead and rewind this and see how much of this you can do yourself if you haven't already. So we've got A, D, B, B, D, C. So that's those 2 angles. We've got ADC, which is the big angle, right? And so when we're talking about angle addition, angle 1 plus angle 2 is the whole big angle. So ADB plus BDC equals ADC. The 2 small angles added together equals the big angle. We could also call this angle 1. We could call this angle 2. So there's lots of good ways to name an angle. Notice that all of these have the D in the middle because the D is the vertex. Your D is never going to be at the end. You can't say A, B, D because A, B, D is this angle right here. And it doesn't even have that line segment between A and B, right? So ABD would be this right here. If I did CAD, that would be all the way out here. This is why I trace these things, because you can see if I trace it with my finger, I always have to have the D in the middle, right? CDB, ADB, CDA. It's always going to be in the middle. Okay, protractor postulate, this isn't a big deal, but we're still talking about angle addition. So if I'm trying to find the angle right here, what I need to do is measure it. But I'm not measuring it from 0, right? I'm measuring it from 20 to 140. Well, how do I do that? Well, it's just like our one-dimensional distance. Let's talk about it. The measure of ABC, how big is it from 0 to C? Well, it's obtuse, so it's bigger than 90. It's 140, or sorry, it's 100 degrees, right? We're using the number on the top, not the number on the bottom, because it's bigger than 90 degrees. So all the way to the ray BC is 100 degrees, but from 0 to A is 20 degrees. So we could do 20 minus 100, or you could do 100 minus 20. It doesn't really matter. Because my starting point is 20, my ending point is 100, 20 minus 100, and then the absolute value of that is going to be 80 degrees, right? So we're going to be doing a lot of work with angles because angles is one of the basic building blocks of geometry. So the angle addition postulate, we talked about this a second ago, but they're going to share a vertex, but no interior points. So RSP plus PST equals RST. Rewind it and watch it again if you need to. But the measure of angle RSP, that's what the M stands for, is measure. The measure of RSP added to the measure of angle PST is going to give you the measure of the angle RST, this whole big thing. Okay, and that's angle addition postulate in a nutshell. You could write that down as a formula and then just fill in what you know. Do you know the measure of RSP? Do you know the measure of PST? Do you know the measure of RST? Once you've got your formula written down, it'll be really easy to figure out what you know and what you don't and how to find what you don't know. All right, bisecting angles. Just like we talked about bisecting segments, a bisector to bisect means to cut it exactly in half. Exactly in half. And so you can already see the congruency marks here. This one mark and this one mark means that angle XYW, this angle here, is congruent to angle WYZ. Their measures are equal and they are congruent. That's why I've marked these with just one mark, one tick mark. They are congruent. So a bisecting angle, this YW, this ray YW, cuts angle XYZ in half, exactly in half. And we're going to be using that a lot. So if this is 45 degrees, this is 45 degrees. If this is 2 degrees, then this is 2 degrees. If this is x plus 3, then this is also x plus 3, okay? And so if this was x plus 3 and this was x plus 3, and they're like, well, how big is angle XYZ? Well, you would just add those two angles together. So x plus 3 and x plus 3 is going to give us 2x plus 6 once all is said and done. Work it out on paper if you want to. And that would be how big XYZ is. It doesn't necessarily have to be just a number. Okay, so 1.6, let's talk about special angle pairs. So complementary, they're going to add up to be 90 degrees. Supplementary, they're going to add up to be 180. Now, one of the ways I remember this is C comes before S in the alphabet, and so the 90-degree angle is going to come before the 180 degrees for the supplementary angles. So, complementary, two positive angles whose measures add up to 90 degrees. Supplementary, two positive angles who add up to be exactly 180. Exactly 90, exactly 180. So here's what it looks like. Angle 1 plus angle 2 equals 90 degrees. You see that square? Angle 1 plus angle 2 is 90 degrees. Angle A is 20 degrees. Angle B is 70 degrees. If I add them together, notice they don't have to be adjacent. If you don't remember what adjacent is, go back and look. 20 and 70 added together is 90. 90 degrees is complementary. That's the definition of complementary. Let's take a look at supplementary. This is also called a linear pair because angle 3 plus angle 4 makes a straight line. See that straight line right there? No interruptions, no breaks. It doesn't look all jaggedy. It's just a straight angle, right? So a straight angle, a linear pair, supplementary angles, that's this right here. So angle 3 plus angle 4 equals 180 degrees always. And that's going to be really important if we're solving for x. If angle 3 is x plus 2 and angle 4 is x plus 1, we know that if we add those together that it's going to equal 180 degrees. And we'll do some examples of that here in a minute. And so we can physically say 3 plus 4, angle 3 plus angle 4 equals 180. And our angle 3 is going to be our x plus 2, and our angle 4 will be x plus 1, and that'll be 2x plus 3 equals 180, and we can solve for x from there. Okay, but I digress. Here's another example of supplementary angles. These are not a linear pair because they do not make a straight line, right? They're not adjacent. But 115 plus 65 is 180, and so these two are supplementary even though they're not a linear pair. They are supplementary, they are not a linear pair. 3 and 4 are supplementary, and they are a linear pair because they make that straight line. They make that straight angle. Okay, and so this is talking about it again. Pause it if you need to. Here's your non-common side. Here's another non-common side, but they share this wall, right? If this was an apartment complex, this is the wall that they share between their apartments, and so one can knock on two's wall and vice versa. But if one knocks on the non-common side, it's not common, so two won't hear it, hopefully. But linear pairs, they make a straight line when they're paired together. Vertical angles, this one's super duper important. 3 and 6 are going to be exactly the same because they're vertical angles. If 3 is 25 degrees, 6 will be 25 degrees. If 4 is 110 degrees, 5 will be 110 degrees. So 3 and 6 are vertical angles. They are the same always, so long as they're made with straight lines, right? 4 and 5 are a vertical angle pair. They are always the same. Always, always. Vertical angle pairs are always congruent. They are always the same. Vertical angles are congruent angles. Vertical angle pairs are always the same. So if this side, if this blue angle is 2x plus 3, then this is going to be 2x plus 3. If this is 2x plus 3, if this is 2x plus 3, then this one's 2x plus 3. So these opposites are exactly the same, only when it's straight lines that are cutting through each other.